Friends, this is my fourth tutorial on AI and data science. In this tutorial, I shall cover the implementation of data preprocessing with Python. Before moving ahead, I would like you to have a look on what I shall cover in this tutorial. In this tutorial, I shall cover the implementation of data preprocessing algorithm with Python. But before moving on to the implementation part of data preprocessing, first I would discuss about the dataset briefly, then about the pre-processing steps, and next how we can access the Jupyter Notebook environment to run the Python code. Let me introduce you about the dataset briefly. Here we have the dataset. In this dataset we have the 4 columns. The 3 columns are the region, age and income, and the last column is the online shopper variable. The first 3 columns are known as the independent features, and the last column is known as the dependent feature. The why we call the last column the dependent feature, because the last column online shopper will depend upon the first 3 columns. The first 3 columns are the independent features, and the last column is known as the dependent because the last column online shopper will depend upon the region, age and income, and whether the person will go for the online shopping or not would depend upon these 3 features: region, age and income. What is the what is the age of the person, and to which region the person belongs to, and what is his or her income is, will decide whether the person will go for the online shopping or not. So that's why this last column or the online shopper variable is known as the dependent feature, due to being dependent upon the first 3 columns. Here we can see in the data the 2 cells are the empty. These 2 cells are known as the missing values, and our machine learning model cannot process the missing values or the null values, so we have to replace these missing values by the mean value of the respective columns or by the median value of the respective columns. And second thing we need to take care in this data set, we can see the first column and the last column. First column and the last column is in the text form, means this first variable is in the text form, as well as the last column is also in the text form. So our machine learning model cannot process the information which is available in the data in text form. So this first column and the last column, which is known as the categorical data, has to be transformed into the numerical value so that our machine learning model can easily process this data. So for that purpose, in Python we have the label encoder function and the one hot encoder function that would transform this categorical data, means the first column and the last column, into the numerical value. Here we have the steps in data preprocessing. We have the 8 steps in data preprocessing. First is to import the required libraries, means we will import all the required libraries that will be required to process the data. In the second step, we will upload the dataset on Colab, because here in this tutorial we will work in the Jupyter environment that is available in the Colab. So first of all we have to upload the dataset on the Colab. Then in the step third we will import the dataset, and in the fourth step, once the dataset is imported, we will split the attributes into the independent and dependent features, and in the step 5 we will handle the missing value. As I have discussed in the previous slide, the dataset might have the missing values, so we need to handle the missing value also. And in the next step we will handle the categorical data. Generally the raw data has the categorical information or the data in the categorical form, so we also need to handle the categorical data, means we need to transform the categorical data into numerical values so that the data can be made suitable for feeding into the machine learning models. Next step is to split the dataset into training and testing dataset. Generally we split the dataset into the training set and testing set, and in general 80% of dataset is used to train the models and 20% of dataset is used to test the models. And in last step, that is the step 8, we will perform the feature scaling. Why do we need to perform the feature scaling? As here we can see in the data, in the age variable and in the income variable, means in the second column and in the third column the range of the variables uh, is different. Means in the age variable there is the range from 35 to 47, and in the income variable means there is the range that is starting from the 45,000 to 87,000. So there is the huge difference between there is a huge difference in the range of the age variable and the income variable. So uh, first of all we need to bring both the variables onto the same scale. So to bring the values of both the variables onto the same scale, we need to perform the feature scaling. Now move on to the implementation part of this algorithm. Here you have your Gmail account. You can easily access the Google Colab. In my previous tutorial second, I have already explained how to access the Colab in the Gmail. Let's get started with the coding part. Here you can see the Jupyter Notebook environment. You can access this Jupyter Notebook environment in the Colab. So first of all, we need to import all the required libraries to process the data. We would import the NumPy as NP library, and this library is used for handling the numbers or the numerical values. And then we will import pandas as PD. This library will be used for handling the dataset. And after importing all the required libraries, we will upload the dataset on the Colab. To upload the dataset on Colab, we will use import files from the google.colab, and then we will use the files.upload function to upload the dataset on Colab. Here we can run this cell to upload the file on the Colab. The first cell also to be executed, so we will also run this cell. Now as you can see, the second cell is running, so this step would complete when you will click on the choose file. Here you can choose the file. This is the online shopper file. This contains the data which I have already explained in my PPT. So click on it. So this file has been uploaded on the Colab. Now we can use this file to read the dataset. In my next step, I will have to import the dataset by using the read underscore CSV function. So I will use this read underscore CSV method to import the dataset. Now click on this cell to import the dataset or to read the dataset. Here we can see the dataset. This dataset is that which I have already explained about in my PPT. So this dataset has the 4 variable: the region, age, and income. These 3 variables are the input features, and last variable is the target class, that is the online shopper. So online shopper is also known as the dependent feature, as I have already explained in the PPT why this is called dependent feature. So here we can see the 2 missing values which are represented here by NaN, 1, and in the fifth column NaN. So here we can see the 2 missing values. First of all, we would require to deal with these 2 missing values. That means we have to replace these missing values by the mean values. And one more thing, means in the first column we can see the categorical data, and in the last column also we can see the categorical data. So this categorical data has to be replaced by the numerical values. As we know that the machine learning model cannot process the categorical data, and machine learning models works only with the numerical values. So that this categorical data is also needed to be transformed into the numerical form. And third means the feature scaling, as we have already mentioned in the slide. The range of the age variable and the income variable is different, so we have to bring the range of these two variables onto the same scale. So for that purpose we need to perform the feature scaling. And this head function is used to display the first five records of this data. And if we want to display more records, we can mention here the number. Here we can see the 7 records. And if we want to display the last few records or the last 3 records, we will have to use the tail method or the tail function. Now click on this to get the last 3 records of the data. Here we can see the last 3 records of the data, and here we can see the last 3 records starting from 141 to 143. And in the next step, we have to split the attributes into the independent and dependent variables. And to split the attributes into independent and dependent variable, we have to use the ilog function. Here we can see the first ilog function, and in the first ilog statement, we are extracting the independent features. Here we can see the column. This column, why we are using this column? This column is being used to means access all the rows of the data, and this is telling us that accepting the last column, we will access all the columns, means accept the last column. And the next statement is telling us that we will have to extract, or we will have to access all the rows that pertains to the last column. So the last column represent the dependent variable. So in the second statement, or the second statement will be used to determine the dependent variable, and the first statement will be used to determine the independent variable. Then we will tackle, or we will handle the missing data. And to handle the missing data, we will import the simple imputer class from the sklearn.impute module, and this simple imputer class will be used to handle the missing data. And here we will run the cell to handle the missing data. Here we can see the imputer object. In the simple imputer function, we will pass 2 arguments. The first argument is the missing values, and the second argument is the strategy. Means we will use the mean as a strategy, because we will have to replace all the missing values by the mean value of their respective columns. So we will pass these 2 arguments in the simple imputer function, and then we will fit the data on the learning model. And after fitting the data on the learning model, we will transform the data, and after transformation, all the missing values will get replaced by their respective mean values. And once all the values get transformed, once all the missing values are replaced by the mean value of their respective columns, we will go for the we will just move on to the next step, that is the handling of categorical data. But here, before transforming the categorical data into the numerical values, we can use the ilog function just to display the records of the just to display the columns. Here we can see the here we can see the second column, means that is at the first index. At the 0 index we have the region variable name, so here we can check. So means this column is being used here, means this is being used here, that by using this column we can extract all the rows. Here you can see we are able to extract the all the rows starting from 0 to 143, but this 0 is just uh, index value. So by this ilog function we are able to extract all the rows for the 0 index value, and if we want to extract the all the rows for the 1 index, we can, or the 2 index, we can easily extract the all the rows for the 2 index also. So here we can see in the second index we have the null values in the second row. So in the next step of the data preprocessing, we are supposed to handle the categorical data. To handle the categorical data, we will need to import the label encoder and one hot encoder from the sklearn.preprocessing module, and we also need to import the column transformer from the sklearn.compose module. And the label encoder, why the label encoder is being used here? The label encoder will convert the categorical data into the integer form, and the one hot encoder is being used here to transform the categorical data into the binary values. And the column transformer will simply, here we can see the use of the column transform function. The column transformer function will simply means convert the will simply transform the categorical data into the binary values 0 and 1. And in the next step we can use the fit underscore transform function to fit the data on the learning model, and then to transform the category data into the binary form. And similarly we can also use the label encoder to transform the categorical data that pertains to the target class into the integer form. So by using the label encoder and one hot encoder, we can easily transform the categorical data into the numerical form. And once the data get transformed into the numerical form, we can easily use that data to feed into the machine learning models. And in next step we will split the data set into training and testing data sets. Generally the data set is split into training and testing data set into the ratio of 80-20. 80% of data set is used to train the model, and the 20% of data set is generally used to test the model. So to split the data set into training set and testing set, we will use the train underscore test underscore split function, and we will import this function from the sklearn.model underscore selection module. And then we will split the independent features as well as the dependent features into the training and testing. And similarly we will split the independent features into the training and testing. So for that purpose we will use the train underscore test underscore split function, that means to split the x and y into the training and testing. And here we can see the test size, that means we are using the 20% of the 20% of data as a testing size. and here we are fixing the random state 0. The random state is set to be 0 so that the if we run the algorithm multiple times, the data set should not change every time. The data set, the training data set and testing data set should remain same. Means if we run the algorithm multiple times, the data set should not change. So for this purpose, random state is set to be 0. And the next step, here we can run this cell, and we can also run the next cell. And in the next step is the feature scaling. And why the feature scaling is used, I have already mentioned in the beginning of this tutorial. The feature scale is done basically to bring the data set onto the same scale. If the data set has the different columns and or the different variables, and the different variables are having the different range, so the variable range is brought into the same scale. So for that purpose, we will have to perform the feature scaling. And to perform the feature scaling, we will have to import the standard scalar class from the sklearn.preprocessing module. This standard scalar will convert the data or will transform the data into the standard form. So now use this standard scalar, and now we will now use this standard scalar to transform the data into standard form. Then we can fit the data on we can use this standard scalar to fit the data and then transform the data into the standard form. And similarly, the likewise, the training data, the testing data can also be transformed into the standard form. And here we can run the cell to see the feature scaling. And once the data is scaled, we can check it. Here we can check the data. The original data was different, and here we can see the data after the feature scaling. This data has the 0 mean and the standard deviation of 1. The after performing the feature scaling or after using the standard scalar, the whatever data we will get after transformation will have the 0 mean and the standard deviation of 1. So here we have finished the data preprocessing, and in my next lecture I will try to cover the machine learning classification models and regression models. And for watching this tutorial, thanks a lot. And if you like this video or tutorial, please like, subscribe and comment, and also press the bell icon button for getting the personal notifications about my upcoming videos. Thanks for watching this video.